Hello, welcome to my channel. So today let's look at the Leetcode Flatten multi-level doubly linked list. So the linked list, this doubly linked list has three nodes: previous, next, and child. Um, so let's for a base case. Example 2, we can actually draw it. So because it's a doubly linked list, so I will draw the two-sided arrow. And also it has a child. So I will use this I will use this one as a child. So also it goes to now. So it points now, this child. But so this example, so when we flatten this, it will need to change it to, so it will flatten the child list and then put the child list after the parent node. So yeah, actually, let's modify this example a little. So we can actually have 3 to 4, and so then it will be like this, and then go to the 2, and go to the now. So you don't need to return this. So for this question, it's a kind of obviously that we need to use recursion. I mean, it's easier or more intuitive to use recursion. So let's maybe do some analysis on how do I use the recursion. So for each node, we actually have three except the head node, it doesn't have the previous, but from the second node ongoing, we might have three like out pointer. So one is a previous, one is a child, and one is the next. So so actually for the recursion, we can do a recursion on the child node. So that we, for example, we have a head node. Then we can actually do a recursion of its child node if the child node is not null. Then we do a recursion of the child node. Then we need to actually put this the output of recursion to be the next of the head node, and also we need to connect the tail of this child list, and to point to the next one in the previous. So let's call it next, or maybe node. So then we actually need to, there is only one exception, is if the node is null, then we don't need to have a two side pointer. We just can have one side pointer. Um, so we actually can, but for the actually next node, we can also do a recursion on that because so actually we need to have call the recursion function twice. First is to call on the child node, then call it on the node on the next one. So this is the first possibility. So if child is not null, but if child is null, actually it's much easier. So we can just call the we can actually we can just call this next. I mean call recursion function on the next and put it to the for the put it to be the next of head. So then go further. So the recursion can the maximum recursion depth is it will be n. That's why the space is also n, because the stack depth will be n in the worst case. So this is my thought process, and now we can start coding. So as I said, so this so actually we can reuse the same function. We don't need to have a help function in this, I think. So if head is null, then we can just return head. This is serve as a base case. And so the next is if head dot child is not null, then we can, as I said, we can do a recursion on the head dot child flattened. Let's call this head 2. So yeah, then we actually need also to find the tail of head 2. So let's use a node. Then we can let's do the node next, not equal to null. The node. So after this while loop is executed, the node next node will be the tail of child list, and next will be node next will be now. So then yeah, as I said, we actually need to have we need to record the temp, the temp which is head on next, so that we can connect the node down next to be temp. But actually we need to do recursion on the temp too. So let's actually add this recursion here, because the head on the next might be null. So yeah, so node next equal to temp. Then if a temp is null, is not null, then temp we need to also, because it's you need to return doubly linked list, so we need to put a previous pointer to the node. So similarly, we need to assign the head2 to the node next, and to the headers next, and then also if head2 is not null, then we need to point the previous pointer to the head. So after all of this is done, then we can return head. So that's basically the first branch. So the second branch is a head child is null. As I said, it's this one will be easier. So so what we need to do is do a recursion on the head.next. Then if this temp is not null, then we can point to head, and head not next will be temp, and then we return head. So this is basically conclude, I think, our code, and let's try maybe from those examples, and also check if there is any error in the code. Wrong answer. Okay, so it's not a valid doubly linked. Okay, so there might be something we missed. So oh, okay. Yeah, actually one thing we forgot to do is we need to after we put this we actually need to set the child node as null. So the child node of 1 in this example is still pointing to 3. I think so actually we need to set it as null to conclude this. So actually here we need to add held child is null, and then it should yeah, okay. So let's conclude today's exercise. So if you like the video, please subscribe or click like button. And then thank you for watching. See you.